We've discussed in this class, and you would recall from previous conversations, that trigonometry is all about cyclic or periodic motion, periodic processes, things that continually repeat over and over again. This is real data, problem one for North Carolina. And these are actual calculations that would be necessary for solar panels, for any application involved with that. So graph number one is the amount of actual daylight hours throughout the year. You'll notice that we have here January. This would be January, February, March, April, May, June, July, August, September, October, November, December. Jason, interesting. And what we have here is these are the months and these are the number of hours in a day. Notice that in January, right, we have the lowest amount of hours. Same thing with December. We have the least amount of daylight. Whereas in the summer months, you're going to have a max, right? So that's when you have your max daylight hours. Here you have your minimum daylight hours. Okay, so notice the uniqueness of the graph. Graph number two is one about what we call solar radiation. You'll notice there's more, ironically this time, it's been flipped around, right? It's been inverted. There's actually more irradiance, more radiation going on in the winter months than in the summer months. Now this happens because of in this case North Carolina, right? And in this case the whole Earth. During the summer months, we're actually furthest away from the sun. I know, right? Go figure. What do you notice about sinusoidal curves compared to previous graphs you have done? So I want to just talk about the shape, talk about the curves, talk about maybe if it repeats or not, right? But just write down, take a moment to write down what you compare this to previous graphs you have done in other classes. I don't care. We call these curves sinusoidal. It's an adjective, but when I say a sinusoidal graph, a curve, I'm talking about the graph of sine and cosine. These come directly from the values of the unit circle. Yes. And if you don't have your unit circle, you're going to want to pause me and go get it because you need your unit circle. Okay. And if you don't have one still, print one out. And if you're not comfortable with one, still, you need to go ahead and go back and make sure you watch the videos on unit circles. So given a circle with a radius of 1, that's kind of important, we can draw right triangles for each angle. So remember we had like 0, 30, 45, 60, 90. If we were to draw right triangles for each of those, there would be an x and a y component. Okay. Recall that on the unit circle, there are points on the graph, and those correspond to coordinates, which will be cosine and sine. The x coordinate represents cosine, the y coordinate represents the sine value. Okay. So the values of the x coordinates will yield a graph of the cosine, while the y coordinates will yield a graph for sine. So we're not going to do both at the same time. If you're going to pick the x values, that's going to generate cosine. Okay, and then after that, if we want to do the y values by themselves, we will get the sine graph. Here we go. So recall the unit circle, right? We had all of these right here. All of these angles, for example, this would be quadrant 1. You would recall there's quadrant 1, 2, 3, and 4. And this time, instead of using the actual values from the exact values, right? The radical 2 over 2, the radical 3 over 2, the 1 over 2. I'm going to use decimal values, just decimal values. That way you can see what's really going on here. So you'll notice that cosine begins at 1. And then you'll notice that the values drop, right? They get smaller. So as the angle increases, hint, you're going to want to write this down. As the angle increases, the cosine value decreases. Remember, the cosine is the x, so the x value gets smaller and smaller. At the same time that we are doing this, at the same time as the angle is getting larger and the cosine is getting smaller, the sine is actually getting bigger. Hopefully you're writing this down, right? As the angle increases, the x values decrease, the y values increase. Essentially, this is like your t-chart table, right? Remember, traditionally, teachers have you use a t-chart, right? You do this y, 0, 1, 2, 3, -1. Plug it into an equation, get numbers. That is ugly. We don't do that. Ugly, ugly, ugly. But essentially, this is low-key a t-chart table, even though we didn't really make it. The unit circle made it for us. So here's what I mean by this. Let's assume that we have um, we're making a triangles out of this. So remember, recall this is the y value. This is the x value. So if I make an angle based on this in the unit circle triangle, my x would be 1. my y would be 0. So that's my triangle. Here, I have a slightly smaller x, and now I'm beginning to have a y. This is my right triangle now, right, for 30 degrees. 30, by the way, would be right here. If I have a 45 degree, you'll notice that my x and my y are going to be the same length. And now at the 60, though, my green is going to be longer, and my blue will be a little shorter. How am I getting these numbers? Look at the values, right? Blue, 0.5, so it's going to be smaller than 0.86. And then at 90, I don't have x, but I have a y. Now, if you want to feel better about this, I can go ahead and put one for you, right? Here's your x at 0. Boom. So notice how when we are increasing the values of the angle, right, 30, 45, 60, etc., notice how in the process of doing this, my x gets smaller. The blue lines, right, these blue segments are getting smaller, right? These blue correspond to the values. They're getting smaller and smaller and smaller until they disappear. But in the process, my y values get larger and larger and larger and larger. Again, as the angle increases, the cosine or x value decreases and the sine or y value increases. Active. This over here. So I have this in degrees. Notice I've matched the colors the same, right? The blue is going to be the x, the y is going to be the green. And I want you to mostly focus right now on this right here. Okay, I want you to look at this part, quadrant 1. Look at the blue, right? The green, okay? And look at those, look how those are changing over time. So here's our 0, right? And I go over here, you'll notice that as I'm going up the unit circle, my blue value is getting smaller, my green value is getting larger, right? There is a 0.5 that I promised you, and a 0.866 from our table. Then we keep going. Notice, again, the blue is getting smaller, the green is getting larger. And as we keep going, as the angles keep increasing, right? The angle keeps increasing. Notice that the green, the y-axis, the y leg, the vertical side of the triangle is getting larger, while the x side is getting smaller. Okay, that's quadrant 1. Look what happens in quadrant 2. It's kind of the opposite, right? Because now the green is getting smaller and the blue gets larger. However, the blue is getting larger in the negative direction. That's pretty important. Okay, remember that the green represents sine, the blue represents cosine. So right now our sine is still positive, it's still above the x-axis, but our cosine is negative, so it's in the negative region. You'll know what this means a lot later. In quadrant 3, you'll notice now that they're both negative. Now my y values, my sine values are getting larger, my x values are getting smaller. Both of them are in a negative region. And then as the angles keep increasing, the x gets larger, the y gets smaller. You'll notice, if you didn't get a chance to look at this, on the side over here, you have the graphs. The blue one represents cosine, the green one represents sine. So as I was doing this, right, starting from 0, you'll notice that these actually correspond to each other. I would propose to you that you see this length of this height of the sine is this height of the sine. It's the same length, sorry, same height. That's the y value. If I took this x value, 0.866, and I stood it up, this is the same length right here. Okay, so this length is the same as this length. Okay, that's how these graphs are generated. So the blue one, as we go through the unit circle, you'll notice the blue one does this roller coaster thing going up and down, whereas the green one, go ahead and keep going up, right? And do the same thing, but what we call it's been phased. It's shifted over. Okay. Don't worry about tangent. Tangent's a mess. So what do you notice about the value of sine as the angle increases? hopefully you consider that as the value of as the angle increases, the sine value increases as well. Okay, at least in quadrant 1. What do you notice about the length of the vertical side of the triangle as the angle increases? So remember these triangles that we drew before, the unit circle that we showed you, they keep getting larger and larger and larger, right? The sine value, can't write that down, the sine value of the unit circle corresponds to the vertical side. When I mean vertical side, I mean this right here, up and down. This is the vertical side. What do you predict will happen to those lengths as the angle increases throughout quadrant 2? We saw, and if you need to go back, you can go back, but we saw that in quadrant 2, those y values were decreasing, right? Those sine values were decreasing. And again, we're talking about the sine values, right? What about quadrant 3? Well, in quadrant 3, we saw that they were actually increasing again, right? The sine values, the green ones. However, you're going to want to write a note that they were increasing, but they were negative. So in quadrant 2, they were decreasing but positive, decreasing and positive. But in quadrant 3, they were increasing and negative. Quadrant 4 would be decreasing, negative. This will all come together in a bit. Summary. What do the coordinates on the unit circle represent? Flesh this idea out. Make sure you're comfortable with not only the idea that we presented to you a few months back about the x and the y representing cosine and sine, but now I want you to think about how they represent the lengths of triangles. And as a result, the graphs of sine and cosine. So I have and of course you can always go visit that simulation if you want to go and play with it, and you can add different options. You can change it from degrees to radians, which will be focused on radians mostly. Here are some pictures though to maybe help you better understand what's going on. So notice again that we are taking this point right here and we are corresponding it to this one right here. This is for the sine, this is the sine graph, this is for the y. And then the high one corresponds to that one. Notice that this one is corresponding to that one. And we keep going, right? We just keep drawing it, and we go through the whole unit circle. And after we've drawn gone through the whole unit circle in that manner, we end up with this. This is the graph of sine. Notice, if this helps out, that this, let's see if I can zoom in, from here to here is quadrant 1. From here to here is quadrant 2. Remember you told me in quadrant 1, as the angle increases, the values of sine increase, right? It's increasing, and then you see in quadrant 2, they decrease, but it's still in the positive. This is positive up here. And then you told me that in quadrant 3, that it was increasing, but it was negative. This is a negative region. And then in quadrant 4, it was going to go ahead and decrease, but it was also negative as well. This is a negative region. Okay, so this is simply following exactly what you noticed from the unit circle. Cosine is similar. Where did the degrees go on the x-axis? Did you notice, like in this picture, what happened to the degrees? What replaced them? What are those? If not, go back to your first set of lecture notes. So the degrees didn't simply disappear, they were replaced. Part B. Why is the highest and lowest point on the y-axis either a positive or a negative one? Interesting. So notice that here's the highest point, it's a positive one. Here's the lowest point, and it's a negative one. And by the way, we call this a maximum point. This would be a minimum point. Do you remember the unit circle? Why is it called the unit circle? And if you don't, may I take you back in the day when we talked about this? Given a circle with a radius of 1, right? And you wrote here unit circle. That's why. Because the unit circle has a radius of 1. So if that's the case, the longest you can get is going to be 1 because the radius is 1. So in this case, you have a maximum of 1 because it's a positive, and here you have a negative 1, which is on the other side, but it's still going to be a radius of 1 total from the center of the circle. What would need to be done in order to make the cosine graph? Same thing, right? Same thing that we showed you with this picture, except instead of the y values, we're going to be doing the x values. And the way it works out is we take those x values, and we go ahead and graph them on the y direction. So it's really about the numbers. You take those numbers, in this case the blue ones, right? And if you're following along, follow along on with this blue graph right here, right? And these blue numbers right here. You'll notice that as these numbers get smaller, the graph gets smaller. It's sloping downward. Here's a 0. So you hit the x-axis at 0. And then they go ahead and increase, right? We're looking at the blue numbers, just the blue numbers. Right now they're negative, so they're in the negative region. What will happen is when we're looking at cosine, this is going to be your quadrant 1. This will be your quadrant 2, right? This region from here to here. This will be from here to here is quadrant 3. And then from here to here is going to be quadrant 4. Quadrant 1, remember those lengths are getting smaller, right? In quadrant 2, they're getting larger, but they're negative. In quadrant 3, they're getting smaller, but they're negative. And in quadrant 4, they are increasing and they're positive. For a cosine, we'll have a max here and a max here. So you actually have two maxes. And right here at the bottom, you have a minimum. If needed, this is not part of a lecture. I'll let you decide if you need this or not. But feel free to look at this. Very informative. So if you're still not quite sure where sine and cosine graphs come from, yes, just look at this video. I didn't put it together, but it was pretty good. It's about 17 minutes long. The first 10 minutes are sufficient. You can put it on faster speed. It will be good for you. Not bad. If you want more understanding, check it out. Summary. Explain how the graph of sine is formed from the unit circle. Then explain a way to generate the graph of cosine from the unit circle.